Hello, everyone. I'm Jim Fraser. I'm along with Gavin and Steve Banker. We're on the supply chain team. We'll be talking here about the digital product passport framework, which to me is actually sort of a top-down approach. We've heard some great application and use cases today, but this is an all-encompassing approach that leaves out hopefully nothing from your project conception all the way to retirement. And it also includes all the pillars of sustainability: economic, social, and of course, environmental. This is just a very brief overview. I know that myself and Steve have written quite a bit about this in our online news magazine, Logistics Viewpoints. So there's over 6 or 7 pieces that if you'd like to learn more, you could take a look there, logisticsviewpoints.com. So let's get started. So what is a digital product passport? It's digital records containing product data from creation to disposal across the entire life cycle of the product. And why are they more important? But even in our everyday life, we want more trust and transparency in everything we do, from our kids' school to the food we eat to where our taxes go. And that's something that as consumers we want, and certainly in the larger sense, the industry is looking to do as well. And then, as Gavin so eloquently communicated to us, there is regulatory pressure, a plethora of regulations across not only the environmental world, but labor and economics. It's becoming a much more complicated regulatory world. And certainly those shift very frequently, as we've seen in the last couple of administrations here in the US. So, let me back up a second there. So this is what we'll learn today: the concept and importance of digital product passports. We'll look at technological components, a number of them. We'll again examine those requirements and explore how to implement. No, I'm getting stuck. So, real-time data and tracking. This is our IoT component with real-time or near real-time sensors, and it ensures compliance with handling guidelines, again, across that life cycle. And of course, if it can be measured today, it is measured. It's particularly useful for perishable items, particularly food and pharmaceuticals, where it's being used. That's probably the best use case today. Of course, all those IoT sensors generate vast amounts of data. From that, you can determine risks in the supply chain. And today, with predictive analytics, you can certainly identify challenging points where you might want to focus your attention, and AI can even do an even better job of that as we move forward. But it does identify patterns and predicts outcomes and enhances operational efficiency. The AI itself could also query all that data for bad actors, so you have no bad actors in your supply chain. And of course, it minimizes waste and reduces costs. Gavin touched on some of these, but in particular, the ones that digital product passports are really focusing on and address today are, of course, GDPR in the EU, which requires consumer consent for data usage, and it implements strict data security measures that you are required to implement and document and deliver to the regulatory authorities. And of course, also in the EU, there's eco-design regulations encouraging energy efficiency, waste reduction, and transparency across that whole product life cycle. Now, it's not only the EU, but there's a range of global standards that you'd like to align with as well. And of course, if you don't adhere, there are financial penalties in some cases, but the larger penalty may well be simply in consumer trust. If you do something that is not looked on as perhaps being a good corporate steward in the world of today. Implementation strategies. The first thing to do is assess your organizational readiness. Evaluate the current infrastructure and capabilities. Not only your physical hardware and software, but your people and your processes. Identify those gaps and areas for improvement. And then consider some pilots. Don't roll it out all at once. You might have some very large challenges there. But small-scale trials are recommended before the full deployment. And iteratively gather data so that you could improve on your next iteration. Engage stakeholders early in the process. And this is a broad collection of stakeholders, anyone who touches the system, not just the person that has access to the dashboard. And leverage best practices in your industry and across industries. So what are the benefits? It enhances supply chain transparency by real-time visibility of product movement. It builds trust and consumer confidence and really demonstrates a commitment to ethical sourcing. And that, whether it be in the industrial, commercial, or retail world, is really on the rise today. It supports circular economy initiatives and encourages recycling, reusability of those products. And of course, it facilitates compliance with regulations, reducing the burden of dreaded manual audits. So what are some future trends? Well, the advances in quantum computing for enhanced security will give you 100% reliable real-time visibility of products through the supply chain. As we all know, there will be wider adoption day by day, week by week of AI for predictive insights. IoT sensors continue to follow Moore's law and are getting smaller, faster, with better data sets, leading to more accurate and cost-effective solutions. Of course, in the world we live in, there's an increased focus on sustainability and circular economy, not only by the requirements of consumers, but also legislatively in many jurisdictions around the world. So, what key takeaways do we have? Digital product passports are essential for modern supply chains. They ensure accountability and traceability. Technology integration is the key, particularly IoT, AI, and blockchain to have immutable records. That compliance builds trust in the customer, and trust is something that's challenging to build. Following those regulations protects your brand reputation as well. And future innovations will enhance digital product passport capabilities. Not only those three technologies, but there's many others that are in the pipeline that will allow it to grow.
So I will, do a few words to begin. Then we'll introduce the Valmet people and have them come up. Who's doing the slides from Valmet?
I can do them.
Okay.
I'll take them.
Marissa will do those. So we have Chris Gephardt, Marissa Davey, and Michael Davis from Valmet joining us today. So we'll be talking about modernization of existing plants and processes. This is something I've done a lot at ERC. We're going to dive right into control systems. I know there's a lot of things we can migrate. DCSs, instrumentation, even valves, applications, and so forth. But today we're going to talk about systems. I think that's probably the most important thing to talk about. We first started talking about this topic about 21 years ago. It was actually the Y2K crisis that started the whole movement towards migration of control systems. Everybody was worried that their systems wouldn't be able to meet the Y2K requirements. Of course, that didn't really come to pass, but that really was the birth of control system migration and modernization. So I want to say a few introductory words. We'll have Valmet come up and do a presentation, and then we'll do a panel discussion. I would like to prioritize the panel discussion if we can. So I hope everybody has questions to ask. And I'll start with a definition of migration. Some people call it migration, some people call it modernization. It's really all the same thing. So when you're talking about systems, you're either talking about transitioning from an old system to a new system, either from the same supplier or your existing supplier. And you're either going to do that in a wholesale pattern, right? Rip and replace is a term that people typically use. Not something that a lot of people like to do. Most of the time we see phased migration of control systems happening. That typically happens at the HMI level and then progresses down through the IO and eventually the wiring. But I want to address the situation that we've had in the process automation industry and really all the manufacturing for a long time. And that is, why the heck do we hang on to these systems for so long, all right? It always amazes me. You know, I've done actually end user projects with people in the oil and gas industry and people in the chemical industry. A lot of users view control systems in the same light as heavy metal assets, you know, on-off valves, instrumentation, things like that. You know, pieces of metal that can sit in a plant for 30 years. If it ain't broke, don't fix it. A few years back, we did some research on how big the market opportunity is for control system migration. We determined that the available market for systems that need to be modernized was about $65 billion. And this was probably about 15 years ago. I don't think it's quite that big now, but I would safely say that the installed base of systems out there that need to be modernized are in the tens of billions of dollars still, because a lot of those systems that we were looking at 15, 20 years ago have now aged out. They're not really being aggressively replaced. And I think the message today, and just out of curiosity, that's eBay, right? So I grabbed some screenshots off of eBay this past week, and these are parts for things like Bailey Infra 90 systems, Bailey Net 90 systems. Some of you older guys in the audience probably know what these are. I'm willing to bet a lot of the younger people don't know what they are, but these are old components, right? I mean, these go back like 30 years. You can still buy them on eBay. They're still keeping these systems going. And what we have today is these old systems can really hold you back when it comes to meeting these sustainability metrics today, right? So we sort of had the first wave of migration that was related to Y2K. We had a second wave of migration around maybe starting in 2008 through 2015, when the users realized that the install base of systems that needed to be migrated was just so huge, they really had to do something drastic, right? And that was another big wave of migration. The third wave today is driven by sustainability. And those old systems can really hold you back, especially when it comes to things like realizing increased energy efficiency, if you want to integrate renewable power sources into your manufacturing process, and other things. So here we see typical component life cycles for a system. Wiring obviously lasts 40 years, depending on the environment you're in, right? If you're in a refinery on the Gulf Coast, where you have a lot of corrosive atmosphere, it's probably going to be less than that. I've heard case studies in the past of people holding on to systems to the point where the wiring is literally brittle. If you touch it, it will disintegrate. I like to think that's not happening anymore, but we have I/O and termination panels, which typically last 20 years. Controllers, 15, maybe 20 years. Displays, that's probably a little non-conservative. I'd say they probably last, less than 20 years at this point. And workstations and controllers. So this is still a big issue. Now it's being driven by sustainability. Another thing I want to point out is that automation, the strategic value of automation is always undervalued, right? I've been doing this for 30 years. We have always had a problem in this industry articulating the value that automation brings to our enterprise. So what I have here on the left side is the percent of project spend, right? Piping, vessels, and structures, big pieces of rotating equipment and bulks. These all take up the vast majority of spending that you have on a typical project. This is a typical refinery or a petrochemical plant. The automation stuff typically accounts for 1% or less of the total cost of the plant. But if you look on the right side, the impact on operations is huge, okay? Automation is the brains of the plant. You cannot underestimate its strategic value. It's got a huge impact on your operations, huge impact on downtime, huge impact on reliability. We did come up with some guidelines back when we first started covering this migration topic. We came up with a list of criteria that you should use when you migrate your system. Again, this is a bit dated, and I'll go over some of the more modernized ones on the next slide. But obviously, if there's a threat of impending downtime or an unscheduled shutdown, maybe time to migrate, right? No longer cost-effective to support the old system. It's dead-ended or phased out. No spare parts availability. Time to migrate. Although I've seen users who will set up instrument shops and keep these things going for 30, 40 years. So the old system might not be able to support new information technology that provides an economic advantage. You might miss out on a new or an emerging business opportunity if you don't modernize. You may not have visibility that could prevent things like abnormal situations or equipment breakdown or supply chain disruptions. Or it may just not have the capacity or be cost-effective to expand anymore. Now, these are some of the guidelines that we've added in the wake of sustainability concerns, okay? A lot of old systems today can't support today's regulatory reporting requirements, right? Like we just went over in the last presentation. Old systems cannot support advanced energy management functions. Old systems cannot support the right cybersecurity controls and features, all right? Cybersecurity is part of sustainability, and cyber resilience is part of sustainability. If you don't believe me, read the sustainability reports of companies like ExxonMobil and Chevron. They all mention cybersecurity. Old systems cannot reasonably support the integration of renewable energy sources into your manufacturing process, such as wind and solar. Old systems do not provide adequate visibility into sustainability-related metrics. Old systems require a large amount of custom integration to reach these sustainability targets. If you decide to hang on to your old system and try and make it work, you're going to spend a lot of money customizing it to make that happen. And those systems cannot effectively integrate with other system domains, right, that we see a lot of right now in terms of integrating power and process control and other domains. So, with that said, I would like to invite Valman up and do their portion of the presentation here.